Hi everyone, this is a video lesson of 4.3 Vertical and Horizontal Asymptotes Part 2. So again, if you haven't watched Part 1 yet, go back and press play before you continue with Part 2. So in Part 1 we talked about the warm-up, we did examples 1, A, B, and C. Let's continue. Example number 2. Determine the equation of the oblique asymptote for each of the following. If you look at part A, it says f of x equals to 2x squared plus x minus 1 divided by x plus 1. So the reason why you can tell there's an oblique asymptote is because the exponent at the top is exactly 1 larger than the exponent at the bottom. That's how you can tell. So to find the oblique asymptote, again, you have to divide. If you write down the coefficients of the top, 2, 1, negative 1, and negative 1 at the front, here's how you divide. And again, I just want to give a little bit more, just in case some of you forgot how to divide. And you have to be mindful. If you're dividing by x plus 1, what you're really doing is isolating for x. So x equals to negative 1. That's how we know it's negative 1. Again, same 3 steps. The first step is to copy, bring the 2 to the bottom. Step 2, multiply, negative 1 and 2. So negative 1 times 2 is going to be negative 2. Then you're adding. 1 plus negative 2 is going to give you negative 1. Then again, you're multiplying. Negative 1 times negative 1, which is 1. And this will always give you the remainder. So you go back, and now you realize, wait a minute, the remainder is 0. How is that possible? What does that even mean? So normally when you think about the oblique asymptote, you're expecting the remainder to be a non-zero instead of a 0 outcome. So this implies if you're thinking, oh, I know this, the quotient is 2x minus 1. This is the most common mistake. No, do not do this. And the reason is because if you look at this question from a slightly different perspective, let's say you're trying to factor this, look what happens. At the top, 2x squared plus x minus 1, you can factor this as x plus 1 times 2x minus 1. And again, you can copy the denominator. You will notice that the top and the bottom, you can factor x plus 1. This implies f of x equals to 2x minus 1, where there's a cavity, also known as a hole, at x equal to negative 1. And again, if you plug negative 1 back into 2x minus 1, that's going to give you negative 3. So in the example, they're asking determine the equation of the oblique asymptote. The answer is, therefore, the oblique asymptote is going to be none. It's going to be none. And of course, I'm going to give you something more. I want to really make sure that we over-deliver here. So learning above and beyond. Now, I know they didn't ask for the vertical asymptote. They didn't talk about the horizontal asymptote. They also didn't expect you to graph this. But I'm going to show you everything. So if I draw a scale, let's say up and down, left and right by 3, here's what happens. You see, you're graphing a straight line, and the slope of this line is going to be 2. And the y-intercept is going to be negative 1. So you start at negative 1, you go up by 2, right by 1. You go down by 2, you go left by 1, and you keep going. And when you connect them, the graph looks something like that. And of course, let's label this. F of x equals to 2x squared plus x minus 1 all over x plus 1. So again, the whole is right there, located at negative 1, negative 3. And the bonus ideas that I want to reconnect with you that we did from the first page is the fact that there are no vertical asymptotes and no horizontal asymptotes. And that's perfectly okay. Let's keep going. Again, the question says f of x equals to x cubed minus x squared plus x minus 1 all over x squared plus x minus 2. I would like you to try this first. You can press pause, and then when you're ready, press play. I'll be right here. Okay, here we go. So again, when you look at this question, the exponent at the top is going to be 3, the bottom is going to be 2. This is how you can tell there's going to be an oblique asymptote, because the exponent at the top is always 1 larger than the bottom. Now, again, you could divide this using long division. That's perfectly okay. But you know, with a lot of practice, here's what we can also try. Just try factoring. If you look at the top, there's a common factor of x minus 1. So this is also known as factor by grouping. If I only look at the first pair and the second pair independently, in the first pair, there's a common factor of x squared. And in brackets, it's going to be x minus 1. Likewise, there is a common factor of 1, even though that applies for everything. But I want to make sure you can see it. And then you multiply that by x minus 1. If you look at the denominator, x squared plus x minus 2, this is simple factoring. X minus 1 times x plus 2. So now what happens is at the top, because of factor by grouping, now you can take out the common factor of x minus 1. In the second bracket, x squared plus 1, and you divide this by x minus 1 times x plus 2. Again, you can cross out x minus 1 divided by x minus 1. And now you go back to the basics, you can divide. So again, I'm looking at the top. Now, here's the mistake. If you write down 1 and 1, because you're thinking, oh, those are the coefficients, there's 1 and 1. This is almost right. Do not forget the empty parameter. So when you think about this, you're really thinking x squared plus 0x plus 1. Don't forget the empty parameter. And again, you're dividing it by x plus 2. So you put negative 2 at the front, just like that. Same steps. If you copy it, 1 goes to the bottom. 1 times negative 2 will give you negative 2. Then you add them. 0 plus negative 2 is negative 2. Negative 2 times negative 2, that's going to be 4. 4 plus 1 is 5. That is the remainder. And the fact that the remainder is going to be non-zero, that's exactly what you're looking for. So the oblique asymptote is going to be y equal to x minus 2. Again, a couple more things I want to show you. Instead of just saying this is the answer, let's go back a step and talk about the fact that you cross out x minus 1. This means there's a hole located at 1. And again, if you plug it back into x squared plus 1 divided by x plus 2, the hole is located at 1, comma 2 over 3. Also, if you're thinking about the vertical asymptote and the horizontal asymptote, here are the answers. The fact that you found the oblique asymptote, this implies there'll be no horizontal asymptote, which we mentioned in the warm-up in the first part of this lesson. You can watch it on the first part, the video lesson there, and for the details. And for the vertical asymptote, of course, if you look at the denominator, x cannot be negative 2, which means x equals to negative 2. Again, the mistake is a lot of students would say, oh, x can't be 1, so write down 1 as well. And this is not how you do it. Because there's a hole at that location, the only vertical asymptote is x equal to negative 2. Let's keep going. Example number 3. Determine the equations of all asymptotes of the graph f of x equal to 2x squared plus 3x minus 1 divided by x plus 1. So again, here we go. Very doable. By inspection, x cannot be negative 1. So the vertical asymptote is located at x equal to negative 1. If you look at the exponents, 2 and 1, again, the top is 1 larger than the bottom. This means there will be an oblique asymptote, which also means there will be no horizontal asymptotes. So, if you divide this, write down the numbers, 2, 3, and negative 1. Again, you're dividing it by x plus 1, so that becomes negative 1 at the front. Same 3 steps. Step 1, you copy. Step 2, you're going to multiply, then you're going to add, then you're going to multiply, then you're adding again. And the fact that the remainder is going to be non-zero, that's a good sign. This means the quotient, which is 2x plus 1, that is the oblique asymptote, y equal to 2x plus 1. Example number 4, page 195,